what we would like to do is to present you how we have used machine learning techniques in an innovative way to allow us to collaborate together with the client and gain their trust. So, what the talk will be like that. We will explain you our methodologies, our implementation, discuss with you the difficulties, how we overcome them, and finally share with you some of our takeaways. First of all, why claim automation? So in this specific case, our client had the size of claims increasing every year by millions. And they have several hundred claim processors going through this claim daily, and this making decision whether they should accept it or reject it. So it's very important for the business to manage this flow, as well as to free time of these experts to be able to use in a more meaningful way. The second motivation is you want to decide consistently, so that in the past and future you can justify this. And for us, the final motivation was Okay, I just stay here, sorry. I'm not much used to it, talking on the microphone. So, and the last motivation for us is to be able to create a platform for collaboration, as I said, so that we can approach other kind of application with similar kind of mindset, analytical perspectives. So, like in many other insurance companies, they had already available automation engines. These automation engines, they are rule-based engines. They were justified medically or business rules. What I mean by that, if you had a female patient that submit a claim with a prostate exam, you know that there is something wrong here. Or if you know that a client submit a claim for a dental procedure and he doesn't have a dental plan, you know that you cannot accept this claim. And this rule, they are actually covering about half of the incoming claims and aggregation of these rules. When we were talking to the client, we also realized that the medical rules, they do actually a rather good job. They were able to cover about 85% of the incoming claims, which means that they could make a decision to accept or reject for about 85% of the claims. The remaining 15%, these are difficult claims to be covered by simple rules, and they required much more work. It was also focused for the company to be able to reduce this 15%. So even though ultimately objective should be to move claims from the red side to the gray side, we have decided that let's focus to the pain point and let's look at this 15% and then actually 10% not automatable claims and justify our decision medically. So before I will go into the detail how we have implemented that, let me talk about a little bit the journey. We start our journey in 2017 with a POC where we have elaborated different models. When we were satisfied with the result and we were convinced that this can work out, we went to the second phase where we built on a static data, on a past data, a model, and we start to collaborate with medical experts to get their buy-in. And in the third phase, we have created a standalone version of this model, this time also based on the past data, but refreshed in weekly and daily basis, and to show the business value of this platform. Currently, we are in the implementation phase where we bring our decisions into the whole system. However, our decisions are used currently only as advisor tool for the manual processors. And the next step will be automating into full automation so that our decisions can be aggregated and handled by any other existing automation system. So, what was our approach? What made it different? As I said, they had several hundred manual work experts passing to look into this claim daily. They were labeling the data, and this was for us like a crystallized know-how. So why not to do the same way as they do it in the past? we could provide a black box that made decisions based on stable data, but we went in a different way. We decided to break down the problem into two parts so that in each step we can get the trust of our client. First, if we have a new claim, we said, let's look at the past and figure out the similar claims. What are the similar claims? Once we have the similar claims, then we can make a decision based on this past similar claims, because each claim has associated decision on the past, and if the majority decisions are accepted, then we can say that this should be accepted. If the past decisions are rejected, we can say this should be rejected. So basically, the democratic, let's take majority vote on that. Okay, it's very simply said and it's easy. However, there is a difficulty here in the slide. It's in the word similar claim. Similarity can be something hard to define. It's a blurry word. You want to say with respect to what similar about what, and you want to say how similar. So, since we are, so this is exactly where the machine learning techniques came into play. So, in our case, since we want to justify our model medically, we are looking medical codes, into medical codes. So in this specific case, there were about 6, for every claim, there were about 6 out of 100,000 codes for our model. So for those who's familiar with it, you know that this is a very big and sparse space. And for others, they are not yet, they will never use this kind of, they will never work with this kind of spaces. Let me give an analogy. For example, they say English language. There are about 200 words, 200,000 words in it, and every sentence is about 10 to 12 words. So it's our problem like figuring out similar sentences. So if I give you similar words, which other words are associated to these words? So I would like to, for example, give an example. If I say food and turkey, how many of that would you associate to kebab? I mean, definitely I am because I'm from Turkey. This is what comes to my mind. And how many of you would associate it to Thanksgiving? And if you are from US, you might be much more affiliated with it and you would think Thanksgiving. So this is not a trivial question, it's kind of complicated. Luckily for us, there are several natural language processing libraries that we could use for our objective. And we choose Word2Vec to create our model. Word2Vec is a library that represents vocabularies in a dictionary using the context, in the way that they appear in the sentences in the documents. So with that, our word in our case is a drug and procedure codes. Our documents are set of claims, set of codes in a claim. So Word2Vec takes these codes, represent them in a vector space. If you want to think, is a kind of memory palace where the words, similar words, are placed next to each other. Once we have this vector space and the position of every code, we can identify also position of a claim by simply doing a vector average over its codes. And then, once we know for every claim where are the position in this vector space, we can also use, for example, cosine distance to figure out all the neighboring claims, nearby claims. So this gives us a setup to say, given a new claim, what are the similar other claims in the nearby. This was the first step that I mentioned in the model, that using that we figure out similar claims. Once we have this setup in place, now we have to take a decision. So if we have a new claim arriving with these following codes, and I want to decide for one of its lines, for its activity, the decision, I look at in the past all the claims that contain this line, this activity, this is drug. For example, do I have to pay for this drug or not? There is a decision associated for each of these cases in the past. This gives us a previous decision set, and we say that if the previous decisions are homogeneous enough, for example, more than 95% accepted, then we say it's accepted. Or if it's more than 98% rejected, and we say it's rejected. So these hyperparameters x and y give us also a framework to create an evaluation setup, which my colleague Philippe will explain you further in detail.
Thanks. Yeah, but before I go into the evaluation, how we did that, let me just go on one point here. You might ask, why are we using now a simple model like k nearest neighbors in that sense? And we have two reasons for that. One is trust building. So using this framework, we can give the medical experts, say, a bunch of claims that are similar to another claim. This is maybe a black box part, but they can get a feeling for that. They can understand, okay, yeah, this new claim is somehow similar to the old ones, or to the other ones. And then the decision, this voting scheme, is really understandable for people who are not doing machine learning every day. And the other thing, actually it's a technical part, you see we have here 100,000 codes. So this means that if we would train just this state-of-the-art supervised classification thing, then we would need to do actually 100,000s of them. We would need to keep that in, to do the validation of that, and it's much more difficult, so we stick to this simpler framework for now. Okay, how did we do the validation, the evaluation? So that's, I guess in this audience this is not too specific, not too difficult to understand. So we used the past data, the historic data, split it into a training and validation set, and then looked how would the training model perform on the test set, as it's the mantra of machine learning. So actually we split up the evaluation into an accept and a reject part, because they are kind of independent up to some point. So for accept, let's say we fix some homogeneity parameter, 95%. You see there's some fictitious results. We could not, unfortunately, cannot show you the real results. We are not allowed to. But to give you the idea, so we set it to say 95% for the accepts. Then we land somewhere on that curve, and we see, okay, we can now decide 50% of the incoming undecided activities in favor of an accept. And we do that at an accuracy of 98%, meaning that only 2% of those 50% were in fact decided as a reject by the manual processing. Yeah, for the reject it's the same thing in red. You specify a hyperparameter, you can give a different one, then you see some of them now will be rejected. This is much smaller amount because there's an imbalance in the data anyway between accepts and rejects. Yeah, and then you get some accuracy. So this is nice for this audience, this kind of evaluation. You know, we are used to that. But now, if you want to talk to higher management in a company, they are not so fond of accuracy and coverage and whatsoever. Hyperparameters, they don't see that every day. So you need to push the envelope further, and that's what we did using an interactive dashboard that we produced for them, where we really calculated the actual business value, or we estimated the actual business value based on the concrete data they had. So how did we do that? Again, we split it up into accepts and rejects because they behave slightly different. For the accepts, you set the hyperparameters, as we did, as we said before, and then the business value, it goes in two directions. So, yeah, I need to say first, this Pac-Man here, that's kind of the, these 50% that we would have accepted, or that our model accepts, now is part of it. So we saw it was 98% accuracy, so the yellow part is the 98%, and the black part is the 2% of wrong accepted claims. How do they influence the business value? So first of all, we do automation. So all of those claims now don't get in front of manual claims processors. So you save the manual processing time of those people. So that's a good thing. But it doesn't come for free. If the model makes a mistake, and it will, then the company, the insurance actually will pay the whole claimed amount of those wrongly accepted claims. So because now for the company it's an accept, that means it gets paid. So that's on the bad side. And this is somehow interesting. So say here, management really can see the trade-off between coverage and accuracy. They can see where do they want to go. Do they want to be more aggressive, or do they want to be more accurate? So that really gives them the value as they need it. Yeah, for the rejects now it's again almost the same thing. We have the automation part. All of those claims that now the model would reject don't get in front of claims processors, so you save that time. It's less. It's actually it should be less because it's less. The volume of the rejects is smaller. Now the claimed amount for the wrong rejects. That's an interesting thing because that's now money that the company won't pay. It won't reimburse. So actually, this comes in this calculation on the plus side. So you know the best insurance is that one that just rejects everything. That's the best business model. No? So no, you need to keep an eye on that so that it doesn't grow too much, that it's not too aggressive, because then you lose customer satisfaction. Yeah, and there's another issue. So the at least actually for all of those claims, but also for the wrongly, more importantly for the wrongly adjudicated claims, they will be resubmitted, or at least part of it will be resubmitted by the provider. So they say, no, you really need to look into that. And then the company will find out, because now it has to do the manual labor. Yeah, indeed, that wasn't really a good thing of that. So that was one of the bad cases. So that goes in the other direction, and then you see how this works. Now the nice thing about this is we did this in an interactive manner. So this is an interactive Power BI dashboard for the management, and they really can play with the hyperparameters there. And that's was amazing how they started to gamify. So it was like a gamification for them. They really could understand what's the impact on the whole process. What would happen with that? So that was an amazing thing to do to keep them invested in the project, or even invest more. And also, so to wrap this a little bit up, for accepts you have the volume is important, and for the rejects, kind of it's more the accuracy. Okay, so let's quickly talk about how did we implement it. So first of all, they obviously have a huge infrastructure already in place. They have a claim management system where new claims come in. They get sent to an enterprise service bus. Now this is not the X-row that's in the keynote in the morning. That's really ESP. And they have the old, as Noel already mentioned, the existing rule-based decision management rule engines in place. They get the new claims via ESP, and now comes in our ICAP. That's short for Intelligence Claims Automation Process. And this is now obvious, do the parallel thing. It's also attached via ESP. And now all of those rule engines do their thing and send it back to the ESP, it sends it back to the claim management system. All the votes and decisions there get aggregated, and finally you have a claim with a possible decision. Now let's zoom quickly into this ICAP. So we implemented this all in an R package. I have to disappoint you, it's not available for download on Plan, unfortunately. But it's nicely split up into several modules, and in fact they are. We have two machines, say, the actual production environment and the training environment or laboratory. And the reason is the production environment is there are dependencies of the whole over productive environment of the company on that part. So this really needs to be hardened, fortified, and so on. But we want to also use the productive data to build our models and to evaluate the models. And that's why we have this training environment, which is part of the IT productive environment there. But it's not as, it doesn't have to be as stable as the REST module that talks to the ESP. So yeah, as I said, we have the create refresh module that automatically creates new models and new candidates of models. This talks to the data source, which is in the productive system. If that's okay, it gets pushed to the validation module that looks whether it's still performing as the standards that we want to have it do perform and other things. If that's true, it gets pushed to the deployment module. And this is now something like the blood-brain barrier there, you know. So this really needs to take the module and put it into the productive environment. This is here our REST module that talks then to the ESP, as we saw before. And now one thing, so that was, I think, one of the questions in the end of the previous talk. Here we have a central repository for our system in place. This one, there are all the decisions and claims, or they're logged, all the data sets that we use, so that at any point it can be, they can go back to the system and see what were the nearest claims that led to the decision on this one claim. So that's one, so that's for auditability, it's important. But also it's important for us to see how it performs, and even we use this as the source for our reporting, where the business value dashboard I talked to you about, this is really based on this repository. So that's a nice framework. Okay, so to wrap it up, just a little bit what were our success factors. So we wanted to really involve business, or we needed to involve business to build trust and create value. And we had several steps or several axes in that direction. So first of all, we needed to establish a framework of collaboration. We didn't want to just put there a black box that now the system talks to and they don't know really what happens there. It needs to be something where they can build trust and understand it. It needs to be transparent because, it's not a tech company, an insurance. It's something that they need to be accustomed and they're important stakeholders there.
And we also look specifically to pain points. I mean, of course, you want to automatize everything manually, but it might not be required. In this case, we have seen that this medical decision were focused and it's a challenging discussion, so we said let's look at only this case.
Yeah, as we said in the beginning, this journey was really important. So that we have different phases where different stakeholders are addressed and they need their own kind of communication and trust building and so on. That was that part.
And finally, we had during the implementation, we take care of the laboratory environment where we could forward all of the things and bring out input that we created and close the cycle basically.